So, ladies and gentlemen, welcome to the final presentations of Collider. And before we start, I would like to give the word to Professor Zbigniew.
Good afternoon, ladies and gentlemen. Welcome to the Collider Grand Finale. I am here instead of our rector, Professor Petracek. He's going to come at the end for the announcement of winners. Despite of that, I have to tell you that all of you are winners today because all of you did it. And I'm looking forward to see what did you do. So good luck, nice presentation, and remember all of you are winners. Thank you, Andrei.
It is indeed like that. Nevertheless, we have to go through all the presentations of the teams today. Thank you, Zbigniew, for introducing the Collider. We will welcome the rector at the end of the ceremony today, where he will join us to hand out the awards, let's say, to the final 3 teams that will be selected. So, we have had 9 days of work behind us. We kicked off some time ago on the 12th of February, where we had the introduction to the challenges. We already had a very intensive Friday and that weekend in which we prepared for everything. And after that, you had a week time to do the research, go to the firms, to visit them, to get a little bit more background of the challenges that you were working on. And last week was the whole week working on the challenges. And today is the point where you can finally present the final result of your work today. So a big welcome to the jury who is going to look at your work and will evaluate what you have done. The jury is composed in the following way. So from each firm who provided a challenge that you were working on, there was one representative here. So welcome everybody from the firms. So they will also give their evaluation. And then there will be us, the 4 mentors who were with you the whole time, also to give our evaluation. And what do we look at? First of all, we look at a very simple administrative thing. Do you keep your presentation within 10 minutes? That's easy, that's the easy part. Of course, the overall impression of your presentation, are you explaining your project very well? Does it look good? Can people read the text? Are the diagrams clear, etc., etc.? Also, of course, it is Collider, it is EuroTeQ, we are schools of engineering, so there should be some scientific and technical background of your presented solution. And very, very important, especially for the companies, how applicable your solution is for the companies. So this is also where the representatives of the companies have a very important voice in saying how well your solution fits, let's say, their purposes and desires. We are also looking at the generalization of your proposed solution. Does it not only fit the problem that you are working on, but could you generalize your ideas and your solutions, and maybe even work towards some commercialization? And of course, in general, when there will be questions and answers after each presentation, how well you answer the questions. So each team has 10 minutes presentations, and then there's 5 minutes of questions and answers. As was already said, when the team comes here, you can organize yourselves any way you want. Yeah? You can have 1 speaker, 2 speakers, everybody can be here, a selection of your team can be here and do the presentation. One of you will get this headset for the microphone. The other person, if they are here, they will get the microphone. But it would be nice that after the presentation, that then in all cases, everybody of the team will be standing here. Yeah, then everybody can see, okay, who was that was working on the challenge? We, of course, know, but for example, the people from the companies do not know, and they would like to see you as well. Without further ado, we will have the team presentations today. The schedule was already published some time ago. So we'll have the first block of 4 presentations. Then we have a short break where we can refill, get a little bit of energy. And then in the second block, we will have the next 4 presentations. So I would like to ask the first team, SenseWise, to step up and give their presentation.
Asi jo. No. Could we start?
Yes.
Okay. So, hello everyone. We would like to thank you all for coming, dear mentors, company representatives, and ambitious students. We would like to welcome you to our presentation, SenseWise, to give all your senses a break. Allow me firstly to introduce my team. And myself, of course. I'm Thea, this is Dominic, and we have Pavel, Shimon, Bob, and Marek. We worked alongside, for this Collider, we worked side by side on the Digital Ear Challenge for Asahi. Prasroy, you probably already know our challenge owner from the occasional beer, and from the occasional beer after school or after work. But let me give you an insight of what problems or tech difficulties you could have as a big brewery such as Asahi. You probably note that you are a big brewery, so you have big machines, and with that come big noises, but of course big problems and responsibilities. So you would like to ideally be in control of all of that because you're at a big risk of even bigger losses. So you want something that would listen closely to your machines, detect if any problems are there, and intervene timely. But you're not the only one with this problem. Many other factories or laboratories face the same problem, and it's all over the same again. There's a defect, you're relying on human error, and then being at risk of fatal losses. This is where SenseWise comes with a simple solution. So we present to you a sensor network that is also connected to an AI-powered database or a software, and then again going to a really user-friendly interface for your workers to be happy with. That's the main part. So we went to Velké Popovice, and we took a look around the brewery. We've confirmed that the main sensor that they really lack and they need the most is actually the microphone. They need to listen to their machines. They already have some other sensors. So this is where the prototype SenseWise Mark II comes from. Features 2 directional microphones that send raw audio signals to the master unit that computes the data and sends alert to the operational center if it's needed. So this is us at the factory, and this is our prototype. My colleague here, right here, will be passing it by, so you can have a closer look. This is just the sensor. So this is just our sensor, the 2 microphones that I talked about, but more about the AI from my colleague Dominic here.
Thank you. So I would like to give you some insight on the technical solution we have implemented. We've been given this challenge which shouts machine learning, but we haven't been given any label data that we could train our machine learning models on. So we decided to split our solution into two parts. The first one is an unsupervised learning solution which analyzes the sound. And the second part is a continuous learning phase. For the first one, we look at the sound, we extract as many features we can, and we're looking for weird sequences, some changes in the sound, either in the amplitudes or in the spectrum. We use for that our unique solution using Gaussian mixture models, modeling the spectrum of the sound and expectation maximization algorithm. For the second part, we employ deep reinforcement learning, which really enables us to tailor our solution for the customer. We can really get used to the sounds of their machinery, and we can improve over time. So for the demo, here you can see our application, and in the right down corner you can see what's happening with the sensor. The graph you can see is the spectrum, the frequencies over time from the sound. You can use this to extract what the sound is composed of. Or you can use this to analyze the sound, to find these anomalies. Or machinery.
But the last step of the software workflow is allowing the user then to replay the noises and label it. So you just saw a demonstration of how our solution comes together, all comes together in real life. But this is our solution for Prague, extracted from an extended diagram of our startup vision. As you can see, with our modular solutions, we are confident to say that we could provide various sized companies a turnkey combination of components tailored just for them, from static sensors, detectors, or smart plugs to walking robots or flying drones, all coming together through an AI-powered software and back to an easy, user-friendly interface, such as a mobile application that the worker could carry around, or to the command center. You may now be wondering how much could all of this cost. So let's relate our billing to Prazdroj and to this prototype that has just cost us around 85 euros. But as you know, with series production, we can drastically drop this price. We're looking now at around 24 euros per sensor, maybe even less. If you're looking for an A to Z solution without integrating to your existing infrastructure, then you should count the cost. So along with the master unit, you're looking at around 2,500 euros. But then also, as we mentioned before, we have additional services such as maintenance services or cross-reference data sets and integration into an existing infrastructure, all coming with an additional billing fee. Now, we're confident about our prices. You're looking now at the cheapest solution that you could possibly have, but we would also be saving. Your investments will be paying off, since a qualified estimate of the anomalies detected by experts is around 60%, and you can add up 15% more with our sensitive sensors. By that, you're lowering the risk of losses that may occur and saving hundreds of hectoliters of beer per year, just in Velké Popovice. So think about how much beer could we save all around the world. But let's not stop just at beer. Let's go further. let's see where we could apply our technologies even in other fields. So as I mentioned, factories and laboratories and technology, that's for sure. But then healthcare units, facilitating work and saving time for people, and researchers or preserving nature. Okay, but now we just introduced to you our business-to-business model. Let's scale it up. We could offer you a business to government or scale it down, business to customer. So even we would be accessible even to you to solve your everyday problems. And as I mentioned before, the implementation of our system could go even into other sensors or detectors, maybe the robots or smart plugs, and much more. So to sum it all up, we have a modular solution tailored just for you, for your specific needs, that is scalable, affordable, user-friendly. We have data cross-references and integration into an existing infrastructures. So we'd like to thank you all for your attention, and if you have any more questions, or if you'd like to follow us on Instagram, please do so. That is all. Thank you. Thank you very much.
Thank you.
Excellent, very well done. So we can take questions, of course, first of all, people from Asahi, but the floor is open to everyone who has questions, so I'm just going to pass the microphone around.
Thank you.
Thank you. Thank you very much for the presentation. It was absolutely awesome. The solution looks very well, very cheap, I can say. So it's very important for us. Thank you for it. And it was very fast. And all the time in English is fast for me. So I have just maybe some basic questions. And the first is it possible to detect even lower differences between noises? It was kind of calm environment. And then there was very high-level noises like I don't know, actually, what was it? The clap or something like that, or the tool. I don't know the English word for it. So there is a big difference between the noises. So is it possible to detect in a bigger noise or higher, like noise level, like lower noise levels?
Thank you for the question. Yes, we are able to do that. We have adaptive threshold for comparing the sounds. So this really adapts to the current environment. Doesn't work only like that, and maybe we should show that in the demo as well. That's unfortunate, but that's your question.
I have a second question. It's maybe a little bit strange, but I was thinking even during the last week when we were talking together, and I was thinking if you are going to be successful with this project and you have a very good probe, or how to call it, is it possible to use it, for example, for people who doesn't hear anything? It's not possible to put something what will help them to hear, but to use it just in a form of I don't know, some pop-ups in their watches if there is some dangerous noise like car is coming or something like that. What do you think about this?
Thank you for your question. Myself, I'm in biomedical technologies, and this is a great question, truly. But we didn't look into that during our preparation. We had only 2 weeks, and we wouldn't be able to answer your question just right now. But we could maybe look into it in the future. Thank you.
Thank you. Anyway, I really like it. Thank you.
Thank you very much.
Any other questions from?
Hi there. So my name is Kwang. I wasn't here at the first initial presentation, but really looking back at last year and looking now at the result, it's really impressive. My question would be more related to the device itself and how many actually would be necessary to track what is actually going on in the brewery. So you've been there. You've seen how it looks like. Have you estimated how many would be needed to be able to see what's going on?
Okay, hi. Thank you for the question. We thought that approximately just one for each machinery that is doing some specific noise would be needed. Then if there are more bigger machineries that are not producing that much noise, and then the bad noise is louder than others, then maybe 1 per 4 of these machineries will be enough. But of course, the exact number for each company would be decided by its size. So, but if it gives you an example of the number of sensors, then.
So maybe one additional
So
question.
it's mainly about the problematic places that the problems occur, the effects occur in the most. That's where what we would focus on. But this would require more time to estimate and more time at the brewery, of course.
So maybe last additional very quick question. If you wanted to start a test and learn in the brewery in Popovice, how many devices would you want to deploy so that you would have a relevant result? The minimum, let's say.
Well, we could start always at one per problematic machine to test it out, and if that works, by time we would implement more and more to cover up the whole brewery. So I'm sorry to tell you that we didn't think about it that specifically yet, but for sure there would have to be sorted out a plan for your brewery. For your brewery's specific needs.
Yeah, perfect. Thank you.
Thank you.
We can take one more question from the audience. Other jury members, people in the audience. I see some hand waving going on, but it's probably something different. Oh, over here, yes.
Yeah, so thank you for a very nice presentation. I would like to ask if you have any like numbers that are coming from the recordings you really collected in the brewery in terms of some like precision recall, false alarms and that stuff. So if you can provide some real numbers.
We didn't record that much data. I think that would be statistically relevant to do some proofs on it. But we use those data to get the patterns in the sounds. For example, when we saw the data coming from the pumps, we saw that they have some predominant frequencies, and the frequency kind of normally distributed around that predominant one by noise. So that's why we decided for the mixed Gaussian models, for example. So this is what we use the data for. I don't think, or probably it would be possible to get that much data, but we were quite busy, to be honest, with the stuff we did already. So we don't have literally like statistical evident data. Sorry.
Okay, thank you.
All right, people, let's give a big round of applause for SenseWise. And can we ask the anomaly pulse masters to come up front?
Prosím.
Also worked on the challenge for Asahi Plzeňský Prazdroj.
Testing? Yeah. Great. Oops. Almost done.
Whenever you are ready.
Almost done. One last step. Okay. Great. Zapni. Jo, pojď. Great. A billion years of evolution versus 14 days of code. Can we match the human ear? That's what we will show you today. We are the Anomaly Pulse Masters, and we will be presenting a solution of the digital ear challenge. Let me present to you the current situation at the Kozels brewery. There is control engineers around the machinery. When something goes wrong, they can hear it and act upon it. Due to specific reasons in the Kozels brewery, these control engineers will be moving away from the machines to a control room. But I'm sure you can imagine a lot of use cases for audio monitoring of devices. We are Yeast Beasts, the monitoring and alerting and detecting solution for managing a factory with a lot of machines or for detecting faults in audio. What we provide. You take a bunch of monitoring devices which are very cheap, you connect them via Wi-Fi to an algorithm. We use a custom algorithm which we will be talking about later, and that can detect and present the mistakes that happened in a very simple web interface. Let me show you, maybe right now is the best time, what we did. I will be having a live demo. So to present to you how this works, I brought a machine. This is an electric toothbrush. Normally, it sounds like this. I'm not sure if the microphone picks it up. It's a slight vibration. What we did at home is did a setup. First, this machine listened to the toothbrush in the normal regime for some time. So right now, it learned what it's supposed to sound like normally. But let's see what happens when I play the normal sound. Please, quiet now. And if I introduce an abnormality by pushing on the toothbrush. Now, we tested this in a very different environment, but let's see if the algorithm has learned how the toothbrush should sound. Okay, so there is no alarm, but we have detected that the toothbrush has been broken. I can play the audio we recorded of that. And the engineer can classify this as an abnormal or a normal audio sample to improve further classification. If I press that this is normal, you won't be alerted about it again. If I do abnormal, on the other hand, it will be more sensitive for this specific anomaly. Now, I believe that... Why? Sorry. I believe that true innovation is built on empiric data and repeatable solutions. So Vicky will explain how this algorithm works.
Thank you. Let me start with summarizing the challenges that we were facing with the development of this approach. The first and foremost, we didn't really have any data and even if we had large data sets, the data set wouldn't be labeled, right? We wouldn't really know what sound is normal and what is abnormal. And I'm going to explain this on a traditional supervised machine learning approach. You need to have data and labels corresponding with this data. And the model does a prediction. In this case, it tells us these sounds are normal, these are abnormal. And then we are able to tell if the model was right or not, because we know what is normal and what is abnormal. And we can use this correction information to train the model to predict the labels correctly. But we don't have the labels. So what happens when we don't have the labels? Well, we get a confused AI, and we don't really want that. So we need to be using unsupervised approach, as the previous team mentioned. So what we are doing is that we are not training the model to predict labels for each sound, but we are training the model to say this sound is different than what normal sounds like. The other challenge that we were facing is, again, as the previous theme, continuous learning, because normal and what normal is can change. It can change during the aging of the machine on various other factors, so we needed to take this into account as well. And what were the requirements? Well, first, we need to be able to detect anomaly, right? And second, there's even a possibility to detect what kind of anomaly what sound is. For example, this anomaly is related to, I don't know, broken pump. How do we do that? This is just a brief overview of our ecosystem. Sorry. I'm gonna describe individual steps. We'll start with noise filtering. We take a raw audio from the factory, listen closer to the beginning, Ondra will play it for you.
Yeah. The beginning is the most interesting part. Oh, but I don't have the... No.
And I'm gonna talk in the meantime. And what we do is that we remove speech and steps and other noises that are not relevant to the task.
Starting pump.
Yeah, the speech in the beginning is a really good example of this. If I play this, it's the same sound sample, just filtered. You can hear no speech.
The starting pump.
And this is what we can use for the rest of the algorithm. First algorithm that we have is autoencoder model, and I'm going to explain how this works on an example of images so that we can all visualize it better. First, you need a set of images. They can be just normal images. You don't even have to have abnormal image in this set. You need to transform these images and preprocess them. Basically, you downscale them, you lose some information, and then you train a model to rescale the image back into size and as close as possible to the original. And that's pretty much it. How is this useful? Well, what happens if you feed the model abnormal image, right? The model has never seen a cat before. So what's the reasonable thing to do? Well, the reasonable thing to do is to say, yeah, this is a black dog. I've only ever seen dogs in my life. It's obviously a black dog. And this is how we can say that the signal was probably abnormal or different from all the other sounds that we've seen, because
it's unable to be reconstructed.
It should be a cat. The other algorithm that we have works on the principle of vector databases. We take a large amount of numbers, which is the audio input, and using signal processing, such as smell, frequency, stutter coefficients, we are able to take this large amount of numbers and make a small large amount of numbers. And these numbers can then be used to compare similarity. You insert these numbers into a database, and this is a visualization of the database. You can see that the abnormal sounds here in blue tend to be kind of similar with this representation. You can even use this to detect anomaly types, as I was saying before, because, for example, our pipe issues will be close to each other in this space. This also allows for parameterization of the sensitivity. For example, you might want to detect all mistakes and have more false alerts, or vice versa, or you just want to have the most correct classifications, and you can all adjust for this. We tried this. We downloaded a data set with normal and abnormal sounds of machinery, pumps and valves. We added noise, and Ondra will play it for you, what it sounds like.
Yeah, you can hear the pump in the background, like a splashing water sound. Then there is a voice, speech, and also some footsteps.
Yeah, the dataset was actually pretty hard because I wasn't able to say what is normal and what's not.
And sometimes there is a sprinkled in abnormal sound, abnormal pump, and we try to detect that.
And we were able to achieve 95% accuracy with this, and Ondra will tell you more.
So by now, you hopefully believe that this works. We tried to show you all the data, so let me tell you the main advantages of this approach. We achieved, I think, a very high accuracy. In all of our datasets, we achieved around 96% accuracy, and we think those datasets are very representative. The implementation of this is very, very straightforward. I basically implemented it right here. All we did before was play this sound to the machine for quite a long time so it can learn how a toothbrush should sound. Now I can basically deploy it, and it will work just as I've shown you. I have already reiterated this. Most of AI approaches need people who create the data set, who listen to the sound and say, is this abnormal, is this normal? We do not need this at all. It self-learns automatically what a toothbrush should sound like. We are very cheap. One of these devices costs 100 euros. So all that you need to do, buy a few devices, let them listen for a few weeks, and you get almost free detection, anomaly detection. And you can analyze it in an app. So, did we match the human ear in 14 days of code? No, but we are 96% there. Thank you for your attention.
Thank you very much. So I'll give the word again to the experts of Asai, Plzeňský Prazdroj for questions.
Thank you. Thank you again. Thank you very much for awesome presentation. I like that a lot. The boss, I think. And I have maybe some basic questions. The environment in brewery is full of some disturbing wires. So my question is it necessary to have this device connected just by Wi-Fi, or can you imagine to connect it by wire?
Yeah, it's just internet.
Okay. Maybe a very stupid question, but I needed to ask you because I have a bad experience with this kind of Wi-Fi because there are some disturbation. And I wanted to tell you the toothbrush test was absolutely awesome and super. I like it. It's absolutely awesome. Thank you. I think I don't have any questions. Do you have some?
Yeah, thank you. Great presentation. At first, I wasn't sure if it's yeast beasts or yeast beats, but I know that it's yeast beats now. My question would be more on, we saw the technical part, which is very interesting and makes sense, more on the human part. Have you thought of the testing process for the employees? Because it's a human factor that plays a role here. Some people hear things, some people don't hear things. So do you have a way in mind how to make sure that the way how you pick the anomalies and normal sounds will be reliable?
Well, the further classification is not actually required because we detect abnormalities anyway, but this can improve performance. So my idea is the best way, the most robust way to do this is to go check physically if there is actually some anomaly happening. And I think that's, and you can fill it out like in an hour, you don't have to report it straight away, classify it straight away.
Yeah, we like the challenge-specific knowledge about the breweries, so it's difficult to answer without consultation because we are not that close to this.
Okay. Yep. Thank you.
Yeah, I think you can detect it by actually looking if some fault happened or not. I think that's the best way.
Okay.
I have another question. Have you thought about implementation to our control system? You visit us, so you could see our control system, and I don't understand it. It's like IT thing, but is it possible to, do you think, is it possible to implement it to any control system, or is it necessary to use it like with your application?
Thank you for the question. As you see, the main part is the algorithm itself, which currently runs on the Raspberry Pi boards. And then to demonstrate the results, we use the web application for it. And instead of that web application, it can be integrated to the application or a new application or already existing softwares that are the brewers using. So yes, it is very possible to integrate anywhere you want.
Thank you.
A great side product of being such a large team is that we have to make the communication as standard as possible, so that we can divide the work and work independently.
Thank you.
Are there any other questions from the audience? Yes?
Hi, thank you for the presentation. We really like it. I have a question regarding the metrics that you used for evaluation of your model. You said that the accuracy is 96%. And yeah, accuracy is quite tricky metric for anomaly detection since you have imbalanced data set, obviously. Do you have a percentage of how many anomalies did you detect?
I do. So the accuracy was built on a 50-50 data set of half abnormal, half normal. and I will find it here. Sorry, I see it really bad like this.
Yeah, this is partially what I was talking about with the parameterization. So you can kind of tweak it.
Yeah.
But
Okay,
on
so
top
this is like, the sensitivity is a user configurable setting, and the blue one is what percentage of the abnormalities is captured, and the orange one is the percentage of normal sounds flagged as abnormal. So around the 90%, 95%, you get like 95% of true positives and about 5% of false positives.
Yeah, perfect. Thank you.
And we think this will be improved by the classification.
All right, I think we have to wrap it up with that. So big applause for Anomaly Pulse Masters.
Thank you.
And now we move to two presentations for a challenge provided by Capexus. And I want to invite the workspace wizards to come down over here.
Can we start?
Yes?
Good afternoon. We are Team Workspace Wizards, and today we would like to present our solution of Workspace of the Future challenge. Our first step was to define main goals. First of all, we would like to have inspiring and comfortable environment in workspaces. Next point is planting of greenery. Also, we think that it is very important to pay attention to recycled materials. And one more goal is to integrate smart heating, ventilation, and air conditioning in offices. Now, I would like to give the floor to my teammate Anton.
Next, I would like to introduce a pretty important part of every workspace, especially workspace of the future. Office landscaping is a process when we are planting more plants and greenery in the workspaces. And green walls are compact, modern, and efficient way how we can green up our environment in our workspaces. What are green walls, bio walls, or eco walls? Green walls are structures that usually placed on vertical walls, and we have planted them. There are some plants. Benefits of green walls. We have several benefits. Firstly, it's air quality improving, stress reduction, saving space, and of course, aesthetic and natural beauty. Green walls structure consists of metal or wooden construction. Then we of course have containers for plants where we plant our plants and our greenery. Of course, we have lining or base that holds the soil. Then outer irrigation system that provides constant supply of water and nutrients to our flowers, plants, greeneries that we have. And next, drainage system that used for drainage extra water. Further improvements like lighting and control systems and plants. There are some plants that can be used. For example, ferns and epipremnum. Both of them are efficient producers of oxygen, so we can use them to have more photosynthesis. Next, chlorophytums, spathiphyllums, and ficuses can be used too. They are very special plants, and they're special because they can produce oxygen when there's lack of light, and because of their long or wide leaves. And in the end, I want to say that it really depends what plants and how many plants to use in our environment. It depends on a specific project. Next, I want to give the floor to my colleague, Andrei.
I hope it works. So, my part relates to smart offices, focusing on technologies that can enhance productivity. I believe many companies are interested in this topic because it can help to motivate people to go to offices and encourage social interactions. So during this hackathon, we visited the company Capexus, and to be honest, they have really wonderful office with modern design and smart technologies, so a lot of private spaces, beautiful common space, HVAC and other features that make this office wonderful. But something was missing, and one day, sitting at home and switching my smart lamp through the phone, I realized what it was. So just imagine, what if we integrate all technologies into the phone or into the system that all employees have access to? So on this slide, you can see some features that could be integrated. For example, lighting, which includes we can switch the light on or off or adjust brightness. So HVAC, you can control humidity level or temperature to make your environment comfortable. So office equipment, multimedia, these features are accessed through the phone, which is convenient for employees of the company. Space reservation, so they can view the availability of rooms, reserve the space, ensuring the efficient usage of office environment. And on this slide, I would like to point out 4 advantages of the phone integration. The first one is increased productivity. So as a real lazy person, you no longer need to go to control points. You just can open your phone or switch the tabs on your laptop and adjust any environmental preferences you want. So the second one is mobility. It could be beneficial for companies where employees don't have fixed workplaces. So you have some settings, and they are linked to your account. So if someone wants to change their workplace, they just go and apply all these settings. It's easy, fast, and convenient, I think. The next one is fast integration of new smart features. So we live in digital era, and new features are developed very quickly. So having the system which supports fast and easy integration could be beneficial for a company and can help to keep a pace with technology. The last one is effective management of rooms. I think many of you have experienced these situations and you go through the entire office and try to find an empty meeting room. So having a reservation system on your phone, you can avoid these stressful situations. So keep in mind these 4 advantages, and now Anna and Ira will take over the final part of the presentation.
Yeah, so what about the interior? Our goal is not just to show the connection and fusion with nature, but also to protect it directly. And reclaimed and recycled materials are best for this stuff because they're eco-friendly, they are durable, they are aesthetic, they are safe. And let's have a look how exactly should we use these materials. For example, reclaimed glass will be used as a decoration, the reclaimed wood as a floor covering. Recycled concrete can be used as load-bearing constructions such as walls, columns, or ceilings, and cork materials for the finishing material. and I would like to show you the visualization that my teammate Anna has created.
So, at first visualization, we can see the workplace where we can also specifically see how we use these materials we presented you before. So there is the ceiling made of cork, wooden floors, and walls made by concrete. At the second visualization, we can see the arches through which we can pass between the work areas. These arches made of wood and natural plants. So you can see there is the green walls. Apart from the workplaces, we also made a visualization of the central area that located in front of entrance, and like the feature is that green place around the center. And this central area we can use for relaxation or meetings. It made by wood and decorated with a wall that made of glass pieces. So my teammate Anna will continue.
Thank you. In conclusion, I would like to say that we have created the design of our ideal workspace where we ourselves would like to work or study. Our solution can be suitable for any types of offices. For example, it can be office of IT company, of construction company, or for example, it can be bank office. Moreover, designed environment can increase productivity of people because of some areas and green around. And also important point is an application because it can make our workspace smarter and more convenient. Thank you for your attention. We will be happy to answer any questions.
Very well done. Since the school is almost like an office, we would really like to work and teach over there. So, any questions, please?
Thank you for your presentation. It was really nice, especially the visualization. It's really good work to have these visualizations in 2 weeks. It's incredible. I would borrow you as our architect for the next time. And I have a really concrete question. It's about the planting and the O2 production. If you compare the ventilation and O2 production of, or oxygen production of the plants, do you have any comparison of that? Have you found studies about it?
Could you please repeat once more?
Yeah, if you compare the ventilation, the HVAC system, the usual one, and the plants, if you have any studies, how what's the concentration of oxygen in the air? If you think about that, like, yeah.
Thank you for the question.
Thank you.
We didn't count any numbers, but after our studies of planting. Maybe I forgot to set it in presentation, but there are some type of plants that provide more oxygen during photosynthesis. But as I forgot, said about moss. These types of plants, for example, not very good to use because they're not so efficient in producing oxygen in that space. So that.
Okay, thank you. And the second question is about the smart controlling by mobile device. How would you apply it to current building or on current building to use this building, the BMS system, building management system, to implement the mobile devices into it?
It will be difficult to apply it to current buildings because we aimed at something what will be built in the future. So you need to have systems from one, from one company, for example, Honeywell or Siemens. And in this case, it will be possible to not aggregate, but take all these systems and integrate into one application. But it's important to say that, first of all, depends on the budget of the company. It will be necessary to develop this application, so only employees have access to this. Because in other cases, we can face some problems with maintainability and scalability and security and other stuff.
Okay, thank you.
Thank you very much. Maybe time for one quick question.
I have 4 questions, but I will ask you just for one. I was thinking about how many gardeners you need to have as employees, because there is a lot of plants and a lot of maintenance around this very nice, really pretty nice environment. It's not necessary to say any number. It's just.
Yeah, to be honest, we didn't calculate any numbers, but it really depends on conditions around. For example, you can have an office place with huge windows, so there are a lot of light there, and you can place the plants which can produce more oxygen. And for example, another office, which is with the smaller windows, you can place there only plants that can be alive with that light, but they can produce smaller amount of oxygen. So it really depends.
Okay, thank you. I have one more question. When you have a like pretty digitalized environment, like you plan to make, what happens if there is no Wi-Fi? If there is some Wi-Fi breakdown, is it possible to turn light on?
Of course, no.
What's the backup for this
We can
solution?
use in this way local network. It's not a Wi-Fi, but it can be used like to all our devices can have port, input port of LAN, local area network, and each device could be connected to. But it's not very interesting solution because all of us have telephones, and all these telephones are not so prepared to connect to any cables. But another case I see, we cannot have Wi-Fi, but we can have some device that will have input local area network and produce some Wi-Fi, like local Wi-Fi, that will be some way secured in our organization.
Or simpler, you just can switch to the manual mode and wait when Wi-Fi will be work.
Thank you.
All right, we have to keep it at that. So big round of applause for the Workspace Wizards. And we continue with yet another Workspace group. So please, Workspace Synergy, come forward for your presentation. After this presentation, we will have a short break. We have no plants in this room, so we have to regenerate ourselves with food and drink. The plants won't do the job for us. Yeah.
Okay, can we start our presentation?
Yes, please.
Hello, everyone. And this is our team that are working on CapEx's, the future workspace. So let us introduce our presentation. We focused in our solution in 3 main categories. This is the materials, also technology, and greenery in our office spaces. So let's start with materials, and my colleague Lera will be introducing the materials.
So let's start. Our first materials is mycelium. Our ideas is acoustic panels. Mycelium's natural sound absorbing for various wall panels, and salient tiles in the meeting room or open areas or common areas to reduce voice and create quieter work environment. Mycelium can be molded for various shapes, like in the light furniture components, like chair backs or tabletops or lamp shapes. On the slide, you can see steps how it's creating, how it's work. Finding the meter is the first. The next one is crushing. Following this is addition of ingredients such as flour and water to create optional mixtures. And after that is mixtures put into the models where it shapes, and either it undergoes drying or processing. The another one is mushroom laser. Mushroom laser is environmentally friendly fabric. So mushroom laser is 100% of biodegradable and compostable. So we use organic waste to create it, and we have is naturally biodegradable.
And our next material is Algae bioplastics. It's a great eco-friendly alternative to traditional petroleum-based plastics. Why we would use this material? Because it can be used in various applications such as packaging or in agricultural products. It grows fast and it doesn't require any arable land, and during the growth it consumes CO2. Other great benefit of this material is that it decomposes faster than traditional plastics. In the next slide, we can see the process of how we select and cultivate this material. First, we harvest it, following it with lipid extraction. After that, that biomass goes under purification process when we obtain polyhydroxyalkanate or PHA, which after that will be converted to bioplastic, which can be in the future shaped and molded into products we want to use. And our last material is reclaimed wood. It's a wood which was restored from its original application, so it can be used in second time or more, it's third time. This wood has tighter grain compared to new wood products, which makes it ideal to high traffic areas in homes or in residential buildings. This material also helps us reduce the deforestation, so we don't cut trees and can reuse this material once again.
Okay, so here we introduce the innovative way of integrating the greenery into modern workspaces. So it highlights the incorporation of terrariums, plant-filled rest areas, smart plant pots, and more importantly, the transformation from indoors to outdoor workspaces. Terrariums are not just enclosed glasses, but they are small miniature ecosystems. Their main benefits are that they need minimal care, they can brighten the indoor spaces, and they can better the indoor air quality for reducing the stress and like better productivity of the employees. The smart plant pots, what means smart plant pot? Okay, it means that the pots control the conditions of the plants, some specific plants, and they can refill the plants with water or if it's necessary. And the next is open-air infrastructure. So the open-air infrastructure is meant for transformation from indoor to outdoor workspaces, which will lead to increased employee satisfaction and retention. Secondly, it can improve the, it can boost creativity of the employees, and more importantly, I think it will better the mental and physical health of employees. And the potential and future directions of these things are, for example, terrariums can be used as barometers or detectors for environment impact. Secondly, modular or flexible design of the equipment and staff in open-air infrastructure, it can really do easier for adjusting the place or areas for under other people or other number of employees. Thank you.
Yes, I would like to tell you about the HVAC system, which will be controlled by AI. And basically what does mean HVAC? It's heating, ventilation, and air conditioning system. So it will start on the basic settings. So we are reading the CO2 level from the CO2 sensors. And if it goes higher than normal, then we start in ventilation. The second important thing, it will be counting how much people in the office or in the exact room. So we're doing it not only by the sensors which are mentioned here, so like occupancy, but also we'll use the Google Calendar and the Outlook. And the third one is will be by the weather. So like we know the forecast for next hours or for the next day, so we can start to do it in advance. Yes, and but what will be the AI impact? So it will learn from all manual changes from the user side. So for example, on very short example, you have a meeting, a company have meeting on the Tuesday at 10 a.m., but then it goes for them too cold. So they decrease the level of ventilation. So how will the AI react? Next Tuesday, it will decrease. So it will decrease the level of ventilation, and secondly, it will start to ventilate in advance, in 1 hour before the meeting. So if no changes on the next Tuesday is done, it means that it was a successful decision. And what about the numbers? Why I think it will be in a high demand already within a few years. The HVAC equipment market size will increase almost in 2 times, only in 10 years. And artificial intelligence, it will increase more than in 5 times in 5 years. But about the numbers which, for example, like energy efficiency, we will decrease it in 20%. Also, I would like to say that HVAC system lifespans will be increased in 20%. Most of them just because we don't use them in the moment when we don't need them. That's all.
So let's introduce our floor plan for our office building. So as we said that we have our main idea of technology that we are integrating in. So AI system will control everything in our office space. The data will collect from the sensors, from the weather forecast, and also from our employees. They are like in Google Form, they are writing, hey, there is a bad air quality. Then AI in real time is learning how the employees are feeling in our offices, so the ventilation system can work better. Also, we have here mentioned that everything, meeting rooms, also the ventilation system of our common areas are connected to the AI system.
And also our auto irrigation system is connected to the AI. So when people say that, hey, the plants are very dry, so AI system learnings, and then it makes a more irrigation to our plants. Here we can also show you that we are using our terraces as an open air working space. Also, we are using the rain water to irrigate our plants. So we are collecting rain water underneath of the building. So. And there are also some benefits of our solution. So it's one ecosystem that's working together. That is why we called it synergy, working synergy. It's sustainable because we are working on ecological materials, energy efficiency because the AI system is real-time collecting data, greenery, and biophilic design. That's all from our side. Thank you for your attention.
Thank you very much. So we open the floor again for questions and remarks.
Thank you again for the presentation. It was maybe even better. I really like the connection from the last slide, from the workspace to the whole building. It was really good idea. The next slide. I have the question about the graphs. What are the data set for these graphs about the savings?
The HVAC system, yeah?
Yeah, the graphs with the savings, and yeah. What are the data set for that? Where did you come from?
The graphs they were taken from the open source. I mean, it's market size, which evaluated for every year, and it's potential of the HVAC and artificial intelligence.
Okay, and it's global or it's just Europe?
It's a global.
Okay.
Global market.
Thank you. And the terrarium, the thought about the terrariums, are they connected to the electricity or some water piping, or how can they work?
Thank you for your question. No, they are not connected to any source of energy, but they can be opened once a week, minimally, and refilled or check the conditions of the plant. Because closed terrariums really don't they need minimal care.
Okay, thank you. That's all from me. Anyone else?
Any other questions from the audience? Other members of the jury? People working in offices desperately? If not, then let's have a bigger round of applause. Thanks. And as said, now we need to regenerate as well. So we have a 10-minute break. Refreshments are over there available. And we continue at 6 o'clock. All right, I need a little bit of help from the audience. We're going to do a countdown. 10, 9,
4, 3, 2, 1. So, hello everyone. I'm Oliver from EuroTeQ Colliders, and we worked with Telma AI on a project regarding a natural language interface to their voice bot creation software, Telma. So firstly, I would like to introduce the problematics of programming in general. Imagine being in a foreign country where only a small percentage of the people there speak the languages that you do. Imagine having to go through complex business transactions and legal proceedings, or even just daily life. It seems almost impossible, or at least excruciatingly difficult at the very least. Now, this is very much akin to the world of programming for non-technical workers and non-technical personnel. We've identified a number of key industries where we believe that the divide between technical and non-technical personnel is the greatest, since programming in its current state is very much inaccessible to non-technical users and for people without extensive technical backgrounds. So the industries are as follows. We mainly did this on the basis of our previous work experience. So we believe that this would have application in banking, user web automation, and CRM services as well. Now, how do you make programming as simple as speaking your natural language and decrease the friction between a non-technical user interacting with a program? Well, for us, the solution is as follows. We will have a natural language input, and which will then generate a UML diagram, which is a much higher form of abstraction and is easier to learn and understand for non-technical users. And that can be then transcribed into a number of technical or number of programming languages, as has already been done. Now, for the user experience itself, we're looking at two approaches. So the first one is a sort of node selection mode, where this would represent a UML diagram, and the user would manually highlight what parts of the UML diagram or graph in general need to be manipulated, and then input a prompt. So effectively, the model managing the graph would have minimized the amount of contextual information needed in order to make a change or any sort of attunement of this graph. So that's our first variation of the user experience. The second one is a more traditional approach. It would be a simple text prompt with continual feedback from the managing large language model, where the user would input what they want to do, and then the large language model would infer which parts of the graph needs to be edited and how. So this is one instance of this happening. So it would automatically infer and edit the graph. Now onto the process of generating the graph and managing it itself. We're looking at, in this example, to give you a more visual understanding of the process. So in this case, we're looking at a restaurant reservation bot. So this relates to the topic of voice bot creation in general, as Telma does, our company. So we have a user prompt, which is then stratified, as we say, or effectively the prompt is broken down into individual logistically or logically rather independent components, which can then themselves be turned into subgraphs. So firstly, you generate the instruction set effectively for the large language model, and then based on these, you generate the subgraphs individually for each stratified task. Then our vision for this is to also have implemented two forms of error checking. So the first one would be, well, regular compilation time errors. So if the UML diagram is plain wrong, well then obviously you want to highlight that to the user. But also, since the graph is managed by a large language model that has contextual understanding of the graph, we could then also highlight parts of the graph that would need reorganization or perhaps some subtle edits in order to better fit the vision as described by the user. So moving on to graph minimalization, which is a broad range of techniques that help improve the performance of graphs or reduce the number of vertices depending on some input parameters. So in the case of UML code, we would, for instance, either be minimizing the number of blocks, which would likely correlate to better performance, or focus on performance itself. So minimalization in this context could also mean adding some as well. Now, lastly, we have consolidation, where all the subgraphs that have thus far been independently managed come together to form a final graph, a consolidated one, that effectively contains all the instructions that need be done. So, and lastly, of course, we visualize it to the user in the form of, well, a diagram. So that's that. Now, where does Telma stand in all of this? Now, Telma is a chat and voice bot creation company. Well, they rather provide the software for this. They provide CRM solutions, and they have given us API access into their software so that we could integrate our vision within the bounds of their product. Additionally, their target customer base is non-technical, so that fits very well with our criteria as well. So, and we will show a live demonstration of working with the Telma's API and generating a graph for you here live. So, carrying on, what we would need to do in order to finish this vision and finalize this project would be to have Turing-complete UML diagrams. So effectively, we would need to create a library or license some of these UML to code programs, where we would have generic blocks, they would be logically independent, and all of that, along with some of the graph optimization techniques that we've already mentioned. Now, from the business point of view, how we would be looking to commercialize this is we're basing this off of Patrick's, one of our team members, work experience in banking, and where he has identified a potentially lucrative niche for this concept to be applied, where we're looking at database mappings, so effectively just defining relations and making them transfer in between databases. So obviously, in the case of a bank, this is highly sensitive and is managed by experienced professionals, and this would help effectively lower the barrier of entry for non-technical users and overall management as well to understand these procedures and therefore help improve the cost, will reduce it, and as well as perhaps the performance of these mappings. So, and lastly, from the technological point of view, what we currently don't have implemented and what we're looking at, what we're looking to implement is that we would either fine-tune or create our own LLM that is specifically tailored for text-to-graph applications, or create or just sort of adjust an existing one. Like right now, we're using GPT-4 Preview that is able to generate JSON, so that could work as well. And then we would need to either implement our own bespoke UML to code language, or we could license, as already mentioned, from projects that have already been done. And then additionally, we need to implement the error checking, minimalization, and consolidation techniques as well, along with the abstraction of non-business concerns in the UML. So for instance, logging and security and things like that. Now for the live demo, I'd like to show you a video of how our system works. So, can you see it? Excellent. Yeah, so now you can see the existing graph that has been created by the user. The user enters a prompt, which in this case would be, well, Silly Goose Orthodontics Reservation. So that's the name of the orthodontics office. And they would like to create a reservation bot for automatically managing reservations. Now, OpenAI's API processes this and generates us a graph, which is then shown here through the CMB, and then finally through this. So this is the final product. Thank you very much. Thank you for your attention.
Thank you very much. I'm inviting human-generated questions, please.
Very well. Patrick, can you get the mic?
Hey, thank you very much. I really like your project. This looks like a great deal of work. I wanted to ask you, could you be able to describe a bit the impact of what you've done? It looks really cool.
Well, the impact of what we've done currently is that we're able to take effectively almost any prompt and create a conversation bot for it using all of Telema's modules, including simple branching conversations. So for instance, here you can see that there are open questions, but there's also a binary question, whether or not the person is a returning patient. So our model is also able to manage branching within the conversation and map the graph effectively to fit that description. So yeah.
Okay, I'm very interested in the demo because I think you skipped around because of time reasons. Could you show the input that created this graph? Like, what was the description?
What was the
like,
prompt?
Yeah, prompt, yeah.
Sure. It was Silly Goose orthodontics reservation bot.
And that's the whole prompt?
Yeah. Yes,
oh, okay.
Correct.
Thank you.
Yes, here we have a question from the expert.
Okay, looks pretty cool. Thank you. Have you tried like different prompts? What are your feelings about like where it fails, where it works? For example, like can you tell more about your experience with your own tool actually?
Yeah, so we were surprised at how well effectively it manages to do on conversations that don't require much branching. So for instance, with the binary questions, when there aren't many yes or no's, which result in sub-branching and stuff like that, it works excellent. But when it gets over one, it like the model, because we're using ChatGPT-4, it's not exactly like best suited for text-to-graph operations. So there is some errors once we get a lot of branching depth.
Yeah, and I just want to add to this that we don't have implemented the stratification. So the context is like whole, and it doesn't have a single purpose for the subgraph.
Thank you. Thank you.
Are there any other questions? If not, then let's give a big round of applause for EuroTeQ Colliders. Thank you very much. And now we move on to the presentation by Visionary. We stay into the artificial intelligence domain. Yeah. So the team Visionary was working on the challenge offered by Aurora.
Glasses down. Glasses down. Glasses down. Fine. Okay. Can I move? Yeah. Glass. How? Okay. So we can start, yeah.
Yep.
So, hello everyone, my name is Konstantin, and today me and our team that consists of such wonderful people that are listed here, like Wamo, Kostya, Anya, Natik, and Artem, we will present you a solution for a challenge that was proposed by our team that is called automatic generation of bibliographic metadata as a replacement for manual cataloging. And before we are going to start and before we are going deep in the intro, let's small describe. Like, I imagine like a huge amount of libraries, and it's like a lot amount of people that are working here, librarians. And one of their job is making a manual filling in of the metadata of the book. I mean like a cover and title page. And our team has like find out as like a hit and absent to and provide it as a challenge to resolve. It means like to generate a solution that can transform the images of the books to some text. And one of the part of the technical requirements was to provide this converting to the special format that's called MARC21. It's a special format of the data that was fully covered and was created partially for the librarians as well. So, as you can see that we have created such a solution. It's a solution in general like some kind of POC, fully documented and good enough. And it's pretty efficient by automatic data entry. And let's show this solution. On this diagram, you can see the full structure of such a solution. In general, it's full written on the Python, and it looks like 3 independent web microservices that can communicate like externally. So it means that like they don't have internal communication, but theoretically it can be done. So it's not a problem. Why we have chosen such an approach? Because from architecture perspective, web is one of the common and very popular platform for maintaining and hosting application, and as well, microservices provide for us granularity and modality for the solution. It means like that if will be some additional requirements to extend such a solution, for example, to work. In that case, for example, we are working with for one of the services with providing data using easy OCR. It's a pre-trained model for character recognition and generative LLM model GPT API. So it's in case when it will be required, for example, to use some other OCR, it will be not a problem in general. So, and as you can see, first of the services it provides like on input, it's working with a scan of images. After that, it provides some text that is generated by OCR system. And after that, it provides a next request to second service that it provides with the JSON. Why we have chosen JSON? Because it's also really common and popular on the web development, and as well, it's also one of your common for future data integration with some other services. And after that, it will fill in to third one service that converts from JSON to MARC21. So let's go deep. First of all, let's start from the source service that's called scan to text. So as I said before, we have as an entry point as a start. We have some ready-to-use images of the book, and we uploading the scan on our web service. It proceeds, analyze, and using our mentioned before OCR models, and returns the extracted text. This text can be sent as well as separate HTTP request to second service that calls text to JSON. It, as well, it's using post request, it's sending on our service, proceeding it using GPT API and transform into JSON format. After that, this response is used to send on third one service, JSON to MARC. That in general proceeds as JSON, validate, analyze it, and after that return required for us MARC21 data format. So, what's the benefits of our solution? It's easy to implement, it's straightforward, it's modular, it has huge granularity and modularity. It's really pretty easy to use. And as well, we have used some pre-trained models. And one of it is free to use, open source, easy OCR. I think we can use it because it has a really huge amount of support of languages. And some kind of disadvantage of such a system that reason that we have used a GPT API, it has some cost. And we have calculated in average it's around 3 cents per book. So it's good. So it's a good one. And to show our results, we will provide some small demo. So I hope that you can see my screen. In general, that's our paper. That's our book, as you can see here. So we have three images of this book. Due to our architecture perspective, we have, I forgot to mention that based on our architecture perspective, we have come with modern cloud-native approaches. It means like our application is containerized. It's like running in the Docker. And it provides also some advantages for us. It means like it can be truly say run anywhere, and it's pretty easy to share and to build and to use it. So as well, we have provided some tests. It's really say a lot of them, but this one, it provides a full life cycle test. We call it that way. It means that it provides the whole life cycle that I explained to you before, with all communication between the services. So let's start. But before that, we need to run our application. Am I correct? So here I'll just type a command that will nowadays in our eyes will build and run our application. So everything is true. So let's start. We have, sorry. I maybe a bit quicker than I thought. So we provided this test. They are really good parameterized. And for example, we will run with ChatGPT endpoint. So let's take a look. It needs some time until it will provide for us some responses. So let's wait a bit. And as you can see, it's already provided first kind of a response. It means a response from our first service called scan to text. As you can see, we have already some data like ISBN, like phone number, like name of publisher, title, author, and so on and so on. So let's wait, and oh my God, it's already done. So what we can see here. Second response, I hope that you can see it. It provides for us the JSON formatted data of our previous response. And after that, on the third one place, we see our Mark 21 output. So in general, that's it. Okay, let's wait. And oh, I make it wrong. So thanks for attention.
Thank you very much. Well done. So, time for questions. Mr. Pokorny, for example. Microphone.
Thank you very much for your presentation. I like it. I'm impressed. We will look forward to try it on a large sample of data. And I have a question. It seems that you, when you try transform or map recognized entities like author, title, year of publication to March 21, you didn't use any mapping table, and you will find this data directly from GTP, right?
Can we
because all the way how to solve it is recognize layout of book cover and so on. But I like it this way. But I would like to be sure that this is the way you have used, right?
Yeah, if we will use the easy OCR model, it will recognize only the characters that are in the images. However, if we can use the ChatGPT model, it will definitely generate some more data regarding the book, so you will have more than you have in the images.
Yeah, perfect. I like it. Thank you very much.
Thank you.
Any other questions? I think there was a hand over there, or yeah, okay. 2 questions, good.
Great presentation. I have one question and one remark. So which model performed better? Because I'm very interested in this. Like in the beginning, ECOCR or like inputting the image into the GPT? Or do I understand it correctly? I mean the first part.
You mean like what is performing better? Yeah, it's definitely ChatGPT because EasyOCR just recognizes the characters from the images, but ChatGPT can generate more information or more precise, let's say, word recognition.
Okay, and the remark, you showed your OpenAPI secret key and you should probably change it. So
I will revoke it right now.
We will revoke it.
It's just making sure.
Because it's just for a demo, we have filled in.
Thanks for letting know, everyone.
Can I very briefly appreciate the amount of bravery you have to run a live demo from a terminal in front of everyone, and it works amazing. Thank you very much.
There was a question all the way up.
Yeah, thanks for presentation. It was very impressive. I have two questions. Like, what's the accuracy of this tool? Because, as we know, ChatGPT sometimes gives not correct answers. And the second one is like, we have to pay like some amount of money to use ChatGPT. And how this possible be done? Like, user should create own like account, or you have some general account for everyone?
Yeah, for our services, you just need to provide your API key for this ChatGPT, and you definitely need to register in the platform of ChatGPT and create this and put some money there, as we did it for our testing services. And you asked regarding accuracies. Yeah, we also had a prompt tuning for the ChatGPT, so it won't create any additional data that we don't want to. Definitely, accuracy can be a problem in every transforming model that we use, but for as far as that we know, it generates precise data for the Mark 21 model.
Okay, yeah, great, thanks.
Okay, let's give the poor guy on the all the way up the top who's waving the whole time to ask a question.
Hi. I wanted to firstly thank you for your presentation, and secondly, you mentioned that your solution is containerized.
Yeah, correct.
And I wanted to ask if you factored AWS or Azure costs into the costs for a single book,
like,
which is significantly more than like the usage of ChatGPT API, which is like cents, and the uptime of AWS containers will be like a lot.
So am I correct that like are you asking about like possibility like of hosting such an application in some cloud vendors? Am I correct?
Yep, that's correct.
In general, it's one of the benefits of containerized application. It means like you can run it in any cloud provider. It means, as you mentioned before, AWS. It can be Google Cloud provider, or it can Google Cloud Platform. I'm sorry, Azure, or it can be Oracle or any other. As well, it can be, for example, self-hosted. And as well, benefits of such an application that all of them are stateless. It means like all of them are cloud native, and theoretically, it can be, for example, scalable, such an application. Because for sure, it's need, for example, to provide some additional metadata or monitoring systems, but it definitely can scale.
Yep, thank you.
Thank you too.
Any other questions? One question from me, being a foreigner, so not a Czech person, and you gave a Czech book cover as a result.
Correct.
So how does it deal with all the special marks and accents? And maybe if you go to a different language, like Turkish, which has even different accents?
It's a good point. I explain why. Because some time ago I have tested on Cyrillic book, like, and it was fully like on Russian or Ukrainian. It also all recognized everything. So it's pretty straightforward and good solution, like from that perspective. It can work not only, for example, with Latin book, but with, for example, some other.
Maybe just in addition to this answer, EasyOCR have, I guess, 80 languages possible to use. ChatGPT is definitely much better in this. So both these ways, either OCR like free and payable, can detect like really huge amount of languages.
Okay, thanks. Any other questions? Then thank you very much. Big applause.
Thanks.
And now I kindly ask Team Dorm Power to come down and to give their presentation. Dorm Power worked on the challenge offered by Prague.
My pocket. Klikker je tam klikker, potřebuji klikker. Okay, welcome everyone. My name is Jakub and I would like to welcome you to our presentation. So, our challenge consisted of coming up with an energy community located somewhere in Prague. Now, an energy community is a collection of houses, of buildings that produce solar or wind power or some other type of renewable energy to produce their power. They do it for the benefit of the people living there, for the businesses there, and for the people visiting the community. And our challenge was to find such a suitable location in Prague. So, we found such a suitable location. Many of you might have already visited it. Some of you might have it close to heart. Of course you know what I'm talking about. It's Strahov. Now, I'm going to spend the next couple of minutes talking about why we believe that Strahov is the ideal and best place for such a community in Prague. And I believe that you will believe me at the end of our presentation as well. Now, I'm Jakub. I will talk a bit about the technical aspect and some of the calculation and modeling that we did. And then Honza will take over the people aspect and talk about the impact and the great benefits that this would bring to the inhabitants in the area. Okay, so what did we do? We took a bunch of data from various different sources, which we credited at the end, and we looked at several different aspects to analyze. First, the regulatory burden, because you can't construct and change anything if the regulations don't permit it. Next, we looked at the energy requirements to make sure that we really understand the task at hand. We then looked at some statistics and area requirements to make sure everything fits in place. And then we looked at the infrastructure and how our community could grow. We then looked at the financials, which I believe will really blow you away. Now, the regulatory burden. As you know, there are 3 special historical reservations in Prague. Strahov is quite good in this aspect because it's in the lesser regulation zone, which leaves us worried about one single thing, and that's the views from the heights in this case. The views from the heights is the view from the Petřín Tower, and we're very happy because the Prague Council does give a recommendation, and that is flat solar panels, which is exactly what we choose for our production of energy solution. So, now let's look at the energy requirements. So if you look at this graph, you see there's something off. Like most energy is consumed in winter, and not really much is consumed in summer, which is an issue for solar panels. But not for Strahov for some reason. It produces almost a flat, it consumes almost a flat manner with a little peak in the middle. So what we did, we looked at a very precise hour-by-hour model, which is not something usually done for solar energy models. And we discovered something really interesting. For all months, there is this big peak at the peak hours that solar produces. And this is especially true for month number 6. By the way, that little down, you can see there's like hourly production throughout every hour in the month. And this closely matches for every single month the production of our solar panels. So again, a fantastic solution. Now, we looked at the statistics. We talked to people at SUS to see that this would really work. And we actually identified more than 4,000 panels which you could put on there at 15 total roofs, totally production of 1,460 megawatt, 1,600 megawatt hours, doesn't matter, covers 41% of all energy usage, hour by hour. This is really, really, really accurate, not something you would usually do for a solar model. Anyway, this is again 41%, lots of gigatons saved, we don't care. We care that we have some extra surplus energy. What do we use it for? We put in batteries, we install PV chargers, which we put here on the parking lot, and we expand to the neighborhood and we sell it to the grid. We bring to the next point. The CTU location of these dorms has a very, very special grid. It has a locally administered grid. This means that any solar produced there can be treated as in one house, and it doesn't put load on the wider electric grid. It impacts a lot of people, over 4,500 staff, and there's a great potential of growth. In phase number 2, we would expand to the communities south and east to include them in our energy community. So what are the takeaways? I've shown the existence of a unique solar-matched, high-impact possibility to introduce local energy communities in Prague with great expandability, with a low grid burden, with high variable gains by installation. And this provides a great model target for where to look for other of these communities, for PRE and all the companies doing these. By the way, all of this is in your hands, judges. You have these case studies in front of you, which you can just take, copy, feel free to do so, and just put some extra a few 100 million Czech crowns for building this project into PRE's hands. You're welcome. And now I will hand over to Honza. Thank you very much. Speak loudly.
Okay, so I will switch to this one. So, how it will look like in reality? How it will change Strahov, Prague, and how much it will cost. In first stage of our project, we decided to change the blue areas, and we have already told you about the solar panels. So now let's look at the blue parking lot. We are looking forward to change that to EV hub for electric vehicles. That would include community cars. Community cars would give a prior right to members of the community to take a car, to borrow it, even for a whole weekend. Imagine you as an Erasmus Plus student that you can borrow a car and go on a road trip with your friends, and it's for your disposal. In simple application, you can overview the range available and reserve the car. The members will be charged a small fee for the energy and time spent. From Strahov community will benefit everyone, I'm not kidding. For most of the students, it is the first housing ever independent. And there will be 1,000 students who got to live the experience of Strahov community every year and maybe later decide to found their own independent community and spread by this dissemination to other localities of Prague and motivate other communities to grow. But there is more. One rooftop that cannot fully support the weight of the solar panels will be dedicated for research and development center for the UCEEB, which is Central for Energy Efficient Buildings. They could measure and test their gear in real conditions, and this corresponds with the future plan for Strauss Stadium. There are some costs. We calculated with the price of the EV hub and solar panels and all necessary changes. We expect to be over 2 million in plus in 25 years, which is the guarantee of the production of the solar modules. Over 30 years, we expect the return on investment to be 46%. It seems that 17 years is too much, but don't worry, this is the worst case scenario. We have just received an invoice or a quotation for the installation of the solar panels, which is much lower, and it would greatly influence the profitability. The Strahov Hill has 2 stadiums on it that are about to go under a huge renovation, and we don't want to be the black dot on this canvas. The Strahov community will be scalable and has a high potential to spread. Let's make Strahov a place where dreams come true and ideas could spread to any village in Czechia or to the whole world. We would like to thank the PRE for communication, consultation, and all of the data. PVGIS was vital for our solar models. We would like to thank Mr. Matiášek from Malá Elektromobilita that consulted us and gave us documentation, and Mr. Boháček from Management of Dedicated Facilities from SUS that gave us consultation and all the documentation. Thank you for your attention, and we welcome any questions you might have.
Thank you very much. Since everybody's living in Strahov, there must be many questions, but please.
Don't be shy.
Thank you. Thank you for the presentation and for the enthusiasm. My question would be more on the ROI, because you mentioned a specific ROI. I appreciate that. Did you also take into account the life expectancy of solar panels? That is
Yes, actually, we were super conservative. So we consulted the life expectancy of solar panels. As you know, there's currently solar panels out in space, which still work. And we considered, back in our model, a slow decline in efficiency near the end. But the actually guarantee which we require, which the standard for new projects is 25 years. We calculated with 25 years, we expect the solar panels to at least 30, 35. What value did we calculate the ROI for? 30 years? 30 years. And we still expect the solar panels to outlive everything by another 10.
Okay, thank you. I have, again, some kind of basic question. Have you thought about the statics of the buildings, static of the roofs? Because usually we have a problem to build somewhere these solar panels because of statics.
Yes, so actually we did consider this. We initially calculated with all the roofs, and then we actually paid a visit to Strahov and talked to the building managers there. And they showed us statics models and explained to us that actually only 11 of the 12 roofs can support this. And they have previously done the statics analysis for this specific problem. So we were able to incorporate that, and the one extra building we would use for the research and development center.
Thank you.
Okay, I would like to thank the team. I think you went above and beyond throughout the whole process. And I would like to ask, maybe it's in your report, but I don't have the time to read it now. Since the dormitories will be producing some energy themselves, will this have any influence on, for example, the rent for the students? Will they be able to save some money from this?
Right, so this is up for discussion with CTU. That's not really our call to make. We would love if this would bring benefits to students, i.e. if they could save on the energy if they use it at peak times, for example. We would love if they could charge their EV vehicles for a reduced price. We would see these benefits as viable. The rest is up to CTU.
Thank you.
Any other questions? People who are not living in Strahov and now decide to move to Strahov, finally?
Please do.
Have you made, did you investigate the special, I would say, like, special relation between the months and consumption of energy on Strahov? You know that it's constant throughout the year.
Yes, so that is detailed in the papers. We don't have time to talk about it. I would be happy to talk about it. It's actually super, super interesting. You can see when exam season happens. You can see the first of New Year's. You can see, you can really see when the workers get up and what time students go to bed in which months. It's really, really cool.
Okay, I'll take a look later, if I can.
I think that Suze is talking about reconstructions like every year. Have you thought about this somehow? Because it's going to influence the consumption.
Yes, so they actually finished a large revitalization project. Maybe Honza can mention this.
There was ongoing project. There is one ECP project, which is great, that they have experience with that. They mentioned that one block is about to go, but nothing that would interfere. We had a great meeting that everything was mentioned, I believe, and
yes.
We took it into consideration.
We actually skip some other buildings which might get reconstructed in our calculations. So.
Thank you.
Any other questions, please? Then I have a question. Could we do Collider next year in Strahov?
That is a great question.
I can answer maybe.
Please do answer.
Yeah, like in Strahov there is a huge building, the Mensa Strahov, where the canteen is located. The canteen is on the ground floor, but the first floor is free for conferences. So maybe if you ask to the SUS managers, it may happen.
Also, if you want to cook for the whole CTU, the Strahov Mensa was originally designed to provide meals for absolutely everyone on every campus. So if you want to like cook for, 30,000 people in one night, there's infrastructure for that. So maybe a CTU-wide collider with everyone involved?
Okay, we will take that into consideration. So, big round of applause for Dorm Power.
Thank you.
And now we move on to the last presentation. Can I ask Team Virides to step down and give their presentation, please? So, Virides worked on the challenge offered by Valeo.
your help.
Check. All right. Good evening, ladies and gentlemen, and members of jury. My name is Shrish Kapoor, and I'm here with my team to talk about values transformation vision. Now, before I get ahead of myself and get into the presentation, I want to talk about the quote that inspired the very philosophy of the solution that we came up with. A certain architect once said that a building is a machine. It's like a vehicle, it's a car. But we choose to live inside it, we humans. And that got me thinking. We have such standards when it comes to cars. We want, with each passing year, we want them to be sleeker. We want them to be faster. We want them to be more efficient, and we don't compromise. And why should we? And I thought, why not apply the same standards to the buildings we spend a majority of our time in? With that in mind, let's get to the introduction. Now, the reason my team is part of this collider is to facilitate Value's vision for 2030. Now, Value has already estimated that by 2030, it would have cut 45% of its emissions, not only across its own value chains, but also with its suppliers. Now, that comes to us. What can us humble students do to push that number bigger? How do we make it better? We'll talk about that later. Now, the Value company, we know it's a French multinational company that makes appliances and digital solutions for cars. Also, cute sensors like these. It has over 1,700 patents, so they must be doing something right. But its crown jewel in Prague is the R&D center at Stratnice. It has 900 employees, big servers pumping data into big labs that run 24/7. Trust me, I've been there. It looks like a Bond villain lair. Now, moving forward, here's Value's smart mobility and CO2 reduction goals. It's compliant to the business ambition for 1.5 degree centigrade reduction, and also it is setting science-based targets to achieve those emission reductions by 2030, the ones that I just talked about. It also aims to achieve carbon neutrality by 2050, and we're going to make that happen. Now, our objective, we're going to transform Prague's iconic Value R&D center into a beacon of innovation, blending cutting-edge technology and sustainable practices for a smarter, greener future. How are we going to make that happen? Now, the agenda for this year's Collider was people, nature, technology. We thought, why not use the blend of all three? And this is how we did it. We're going to talk about the economics, the energy efficiency, but we're not going to compromise with the aesthetics and health, because employees, they deserve the best. Now, these changes that we have accounted for will lead into changes that are external and changes that are internal, more IT-based. Now, let's get to the external changes. Okay, yeah, I'm sure what you guys are thinking about right now with the building. Trust me, once we got there, we thought the same. As we arrived at the scene, immediately we were able to come up with some suggestions that would make the building look better. For example, the southern facade of the building, which is directly exposed to sunlight, that area during summers would waste a lot of energy. It's logical. They would waste a lot of energy maintaining comfortable temperatures for their employees. Now, its rooftop that you can see, the topmost part, it's filled with, just vents or something. But what we could do is put solar panels there, a canopy of them. Now, coming to the subroof section, it's ugly, it's barren, it's empty. What we thought what we could do is turn it into an employee's garden, a green roof. Then, coming to the parking lot. Now, from what we talked about and negotiated with the company representatives, we got to know that Valeo wants the building to be maxed out at 1,200 employees from 900. So that's 300 more people. We need more parking space. What are we going to do? We suggested construction of a multi-story parking with the roof of it turned into another solar canopy for energy. So this is what it would look like. This is the current building, and as you can see, there are the suggested changes. The perforated facade is basically for the southern facade of the building. It's a shading solution. The green roof is what I talked about, the roof solar canopy, and the multi-story parking and its canopy. Now, coming to perforated facade, this is inspired from a building in Graz. As you can see, it has this weird paneling. What it does is, it doesn't obstruct the view of the employees inside, but it makes sure that excess sunlight and that heat that we hate in summers doesn't get in. So, no more energy waste. Now, coming to the solar panels and the green roof detail. So the solar panels we have decided to use are monocrystalline panels with around 18 to 20% of efficiency. They're quite nice, bit expensive. They'll be aimed at the sun at an angle and placed on the roof as well as the parking structure, as I discussed. Now, this is the cross-section of the green roof. It's got multiple layers, all because of compliance requirements and safety. This is what it looks like in the end. It's greener, it's smarter, but most importantly, it's much more efficient. Now, every external change needs to be supported by changes in its management. And these are two digital solutions interlinked that we've come up with. The RMS application. RMS stands for Resource Management System. It could be a phone on an app on the employee's phone, or it's an all-in-one management system, unifying Google Calendar, meeting reservations, parking spaces, and any additional features that you might want to come up with. Think employee ID cards or something like that for security reasons. Now, coming to the parking system and its sensors, what we have decided is that when eventually the multi-story parking is going to be built, it's going to have these sensors that would essentially map out and ensure that when a parking space is filled, the employee can access and check for it, so no more 8 a.m. rush hour. This is what it would look like if drawn. As you can see, it's got parking sensors, parking solar panels, rooftop solar panels, and they all feed data into its own main server that is there at the location. And that is going to be running the digital resource management system that I talked about. Now, the additional benefit of this is upper management. Based on authorization, there's going to be a live dashboard that the upper management anywhere in the world would be able to access and look at. And it would have any data they would require for carbon audits or whatever it may be. And this system can also communicate with other R&D facilities of Valeo all across the world. Now, coming to the energy analysis of this. They're complex graphs, I know, but don't worry. All you have to look at is the triangle and the blue band. The blue band represents the ideal. It's where we want the energy analysis to be, but it's not. And this is of the current existing building. For the roof, the windows, and the certain walls. As you can see, they're all far away from the ideal. But when we ran the energy analysis of our new improved building, we were much more closer to the ideal in at least 2 of the cases. So, energy-wise, it's good. It's going to conserve stuff. Now, I'm a finance guy, so let's talk money. The return on investment for this, the estimated cost of building the panels alone, installing them, is going to be around 15 million Czech crowns. I don't know how much that would be in euros. You guys can do the math. But the amount of energy saved per day, according to our calculations, is estimated to be around 3,000 crowns per day. So, if you do the math, you'll see that it'll take only 13 years just by saving alone to make up for this investment that you would be making for the solar panels. And this system lifetime, in the worst pessimistic case, is still going to be alive for 25 years. Now, this is the BIM model comparison. As you can see, the existing building is going to have costs. It's going to have the energy consumption going up, because when you're using energy from a power grid, you're also open to geopolitical problems, external factors. But when you're reliant on your own sustainable energy, all of that goes away. It's a stable line, and the very best, it's 15% less than what value would usually spend. So currently, the existing building, only 1% of it is powered by sustainable energy. But now, it's going to be up to 20, but at the very least, 15%. Now, after this building is transformed, it's going to serve as a benchmark, not only for other R&D buildings that Valio has, but to any building, because it's a philosophy. Because sustainability isn't a rocket science. It's about making small changes that change the world. So, with that, I say, let's change the world one building at a time. Thank you.
Excellent, thank you very much. So let's open the floor for questions and discussion.
Any questions?
I see our representative of Valio is still calculating the overall cost. Anyone else in the meantime have a question? Yeah, over there.
Thanks for the presentation. I would like to ask what's the method of financing? From what did you calculate it?
Should I answer? Sure. Yeah. We asked Valo to provide us their consumption, and we calculated the area that we can install our solar panels, and based on that we had our estimations.
And did you take into consideration any subsidy or loan or other?
No, actually we didn't go to any studies. We just went directly to their consumption. And then we estimated it based on what we can produce.
But the first investment has to be huge, and then you pay it gradually.
Yeah.
So it will be just a huge investment from the firm.
Yeah, but you are putting 3 different parts to the building. You're not talking just about energy. You're talking about mobile application. And for example, you can add another features to the application like digital key, which it's a new building and they don't have it.
Yeah, thank you.
So it's not just one thing. It's not just energy.
I understand.
Yeah.
Okay.
Yeah, can I have a follow-up question? How much energy are you going to produce with all these panels on top of the Valio roofs?
How much?
We
have in the study.
We have it in the study. Not we don't have the data with us right now, but
Where's the document?
We gave the document.
500,000 jet pounds? No,
What?
sorry, 500,000 kilowatt hours per year.
Per year.
Energy savings. So the roughly total consumption of the building is roughly more than 2 million kilowatt hour, and the energy produced by PV panels is roughly 500,000. Now we have only modeled the exterior of the building. We have not modeled the interior of the building. So all this is the direct implementation and direct cost reduction that we are getting.
Okay, thank you very much. I was interested to compare how you managed to put them at the angle. Thank you very much.
No problem.
Any other questions? Maybe some feedback from the challenge owner?
Valo.
First of all, thank you very much for your time and for your effort. And the second was for me very interesting, quite interesting, that not only invest to, let's say, finance, but the second point of view is aesthetic. And it's very interesting point of view that not only invest to the, let's say, technology, but to the environment for employees. Thank you very much for this, let's say, different point of view.
Thank you.
We're flattered. Thank you.
Are there any other questions? Final chance. Then if not, big round of applause for Virides. And this brings us to the closure of all presentations by all teams. So you can relax now, but we, the jury, cannot relax. We now have to do our homework. So we are going to retreat to one floor higher, to room 309, where we will convene and think about everything that we have seen, all your great presentations, and come up with the evaluation and the final results. So give us 20 minutes to 30 minutes max, and then we'll be back here with announcing the results. Thank you very much. Ajeto tady. And we have finished, we have reached a conclusion. But before we are going to talk about the selection of the 3 best teams, first a few words about how things will continue, because if I do that after announcing the 3 best teams, no one is going to listen. So I'm going to take a disadvantage of this moment that I have your attention. So first of all, I have to thank many people for making today's final Collider possible. First of all, of course, the firms for giving the challenges to the teams on which they could work. Thank you very much, and thank you also for being member of the jury today. And of course, the teams, you, ladies and gentlemen, who took on the challenge to work on these open-ended, complex questions during the time of 9 days. Thank you to my colleague tutors who were with us during the whole period. Whenever you had questions or problems, you could turn to them. Thank you very much for the wonderful support by Veronica, Aneta, Libusche, and Aleš to make it, for example, today possible, but also the start of Collider, everything that concerns the PR. Thank you very much. Thank you very much, Mr. Vice Rector Zbigniew Skvor, Romana Pikulova, Pavel Kaudelák, and Gabriela Achtonova for the general support of Collider and the EuroTeQ project. And of course, a big thank you for Mr. Jan Slama and his team for the wonderful technical support that we had, not only at the start, but also today. So a very big round of applause for everybody. So what happens next? As we said, we will select 3 best teams, and they will continue to the EuroTeqathon. The EuroTeqathon will be a competition in which the 3 best teams of all the partner schools of the EuroTeQ Alliance will come together, and they will show their work, their projects. And this year, it will take place from the 8th of June to the 10th of June at the École Polytechnique in Paris. So what will happen? The selected teams will travel on Saturday, the 8th, to Paris. The accommodation is already reserved. It will be the ECLA Paris Massy Palaiseau. And of course, you can take the bus, you can take the train, and if you are a really big sports person, then you can take the bike, and afterwards you can compete in the Olympic Games. And if you manage to reach there by 4 o'clock, then we will start with the real EuroTeqathon at the area of ECLA. Then on Sunday, there will be a lot of training. We will go to the École Polytechnique. We will have training, consultation, pitching, time to work on the final presentations. And in the evening, there will be a social program. And then, of course, the big finale will take place on Monday, June the 10th. in the morning, where all the projects will be presented by the student teams, and again, traditional break and jury session, and then the final 3 winners of all colliders together will be announced. And then we're going to cry a lot, and again, take the bus and the train, and you can, of course, put your bike in the train for going back. So, having said that, the final moment, and can I please invite Mr. Rector to tell us who are the winners.
Hello, good evening, ladies and gentlemen. I'm really happy that I can announce, well, I will start from the 3rd place, I guess. So the 3rd place is the team called Visionary.
Afterwards, we will invite you down to take pictures and stuff. But you can also come now.
Wow, that's easier.
It's easier.
Okay, on the 2nd place,
congratulations.
I see here team Sensewise. And the winner is Team Anomaly Pulse Masters. So, maybe stay over there.
And now we shake hands.
Congratulations.
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 To all of you, I would like to congratulate, and not only all of you, but also all of the teams working on this EuroTeQ, and also to all our colleagues who are supporting this activity. I'm from my faraway place also supporting EuroTeQ, but of course our colleagues are doing that directly, and I'm very happy that this activity is really working, and it's also a part of our strategy to continue in this direction and to somehow integrate with all the partner schools in the consortium, maybe also in other directions, in research, education a little bit more than it is now, and maybe also in other matters. So it's a future, and I would like to thank to all of you that you are part of it and you are supporting this project. So thank you very much.
So with that, we conclude this year's Collider. Again, a big thank you for everybody who took part in the Collider this year. It's not easy, it's complex, it can be frustrating at times, but I think you all did a wonderful job. As Mr. Vice Rector Skor said in the beginning, you are all winners, but at the end of the day, we can only send 3 teams to Paris. But you all did a great job. I think the firms really appreciated all your ideas, fresh initiatives that you brought to the problems that they put on the table. Also a very big thank you to Pańska Technická Liceum. We had a big, let's say, jump into the deep of having students from this school taking part in the Collider in this year. I think and I hope it was a positive experience, and we will surely continue with that. Maybe here, maybe on Strahof, I don't know. So thank you very much, and have a nice evening.